Hi everyone, a very warm welcome back to GradUp Prodigies BCA. This channel is dedicated to helping BCA students learn difficult subjects in the simplest way possible. So in today's video, we are going to start with one of the most important subjects of semester 5, that is operating system. While it is very lengthy and a bit difficult as well, but I'll try my best to make it in short, very crisp, and you will be able to understand every concept very easily and ace in your exam. So if you ever wondered what happens when you press the power button of your computer, or how multiple app run smoothly on your phone at the same time, then this topic is just for you. So we'll first begin with the unit 1 of operating system. In this unit, we'll learn about basics of operating system, what are the functions, what are the different kinds of operating system that are present, and then we'll talk about Linux programming in the second part of the unit. So let's begin with the basics. So an operating system or OS is a software that acts as an intermediary, or we can say it acts as a bridge between the user and the computer hardware. Basically, an operating system manages the hardware sources and provides an environment where application programs can run smoothly. So it acts as a bridge. Here we have operating system, which is acting as a bridge between the user and the hardware, right? And it also ensures that the application programs that the user is running act very easily and smoothly. So in simple word, OS is like a manager. It manages the communication between you, that means you are the user, and the hardware and the software, right? And we can also take another example I have mentioned here, that operating system is like a government of a country. So what does government do? It doesn't build roads or grow food itself, right? But the government manages all the resources. It manages the land, the money, the people, and it also provides the services like laws and infrastructures so that the citizens can live and work productively. So this management of resources, is done by the operating system in our computers. So in real, similarly, operating system manages the computer fundamental resources such as CPU, memory, storage devices, and all the connected input-output devices like your keyboard, mouse, and monitor. So it provides a stable, consistent environment where our application software can run without the needing to know the intricate details of the hardware. Now, without an operating system, a computer is just like a body without a brain, right? So hardware is there, the body is there, but it can't function properly without the brain, that is the operating system. So now we'll know about what are the key goals of an operating system. So there are particular goals including convenience. So what the operating system does, it makes the computer easier to use. So imagine if you had to directly write a machine level code every time you wanted to play a music. So in order to play a particular music, what you have to do, you have to write a machine level code, a complete 100-liner code. So how would that look to you? So the OS save you from that kind of complexity and provide you a convenience of use. Second, it provides us with efficiency. So you see, it uses the computer hardware in an optimal way. For example, when you are running multiple apps on your phone, the operating system ensures that your CPU and memory are not wasted. So it provides a very efficient use and without wasting the resources, using them in very effective way, in very optimal way. And then we have one more key goal, that is ability to evolve. So operating system should be designed in such a way that new function and hardware can be easily added. So for instance, an older version of Windows allowed updates and driver installations for new devices. So what is this? It is evolving with time. We have various versions of Windows which we have right now, so we are always installing the latest version. So this ability to evolve is one of the key goals of operating system as well. So the OS is not just about running software, but it is also about providing convenience, providing efficiency and flexibility to the users. Next, we'll talk about functions of operating system. So this is the most important part. We should know what functions does the operating system perform. So let's go step by step. All right. First, we have process management. So what is a process? Process is basically when we execute a program, when a program is running. So a running program is known as process, right? We'll use this term a lot in our upcoming videos, so you should know what a program is and what a process is. So whenever we run a particular program can be anything, an app or a code, right? So if you are running a code, that running is known as the process. Okay. So to manage that process, so OS is responsible for managing all the programs that are in execution. So operating system handles the process creation, process scheduling and termination. So for example, when you open YouTube and Spotify together, so the operating system manages both the process so they can run without interfering with each other. So operating system will open YouTube and Spotify at the same time. One would be running in the background, one would be in the forefront. So this is how the operating system is managing when to create a process, which one to schedule as per the importance, and then when to terminate which process, right? This is so when the operating system decide which process to gets to use the CPU and for how long, that is known as scheduling. So there are various tasks involved in process management, like I said, creating and deleting process, suspending and resuming processing, allocating CPU time, and also ensuring that process can communicate with each other and synchronize. That means they can perform their task without interfering with each other's differences or changes they have made in their own particular operating system with each other without conflict. So there should not be conflict. If the various sources are accessing a particular, various processes are accessing a particular resource. For example, there are two processes. There is Google and one more process. They both are running and they both want to access the printer. So what will happen? The process management, the operating system will perform its function of process management to synchronize the processes, to make sure that there is no conflict and it is resolved. So there is communication between the processes. Next we have memory management. So memory management, memory RAM is where your computer temporarily stores data and program that are currently being used. So you should know what memory is, all right. So the operating system keep track of every byte of memory. So what is happening in memory, what gets stored, what get out of the memory. Okay, so it decides how much memory each process gets and prevent one process from using another's memory. So all this management of memory is also done by operating system. For example, when you are editing a Word file while browsing Chrome, both applications get their own space in RAM, right? Nobody is taking each other's space. So this management of memory is done effectively by operating system for the convenient and effective use of the to provide a good user experience, right? Next we have file management. So the operating system manages files on different storage devices. Operating system controls how data is stored, retrieved and organized. So for example, when you save a photo on your phone, the operating system stores it in the internal memory and shows it in your gallery app, right? So this is all doing operating system, which is responsible for managing and organizing the file on storage devices. So what happens here is that it presents a logical view of information storage. You are allowed to create something, you are allowed to save, you are allowed to send files so easily. So what is behind that thing? Operating systems function, that is file management. Okay. Next we have device management. So operating system manages all input and output devices like keyboard, mouse, printer and camera. So what operating system does is that it provides device drivers that act as a translators between the hardware and the software. So there are drivers which help or which act as a translators. When we have a hardware, we don't know, hardware and software don't know each other's requirements, so they need particular thing in between, a special software which helps them to communicate their needs. So this is also maintained by the operating system. So when you want to connect headphones via Bluetooth, so operating system ensures the sound is redirected from the speakers to the headphones. So this is done with the help of drivers, which allocates the devices to the process which are needed. Okay. And this process of device management is very effectively done by operating system. Next function is security and protection. So operating system ensures that there is no unauthorized users. So there is no users that have unauthorized access to your system, right? And it provides authentication, it provides passwords, fingerprints, face lock. For example, we have a lock screen on our phone, so who is managing that? Operating system is responsible to manage, to have a lock, and ensuring that the right verification is done to the user identity. So it uses authorization to control access to files and resources, and it also ensures that users can only do what they are permitted to do. It protects the system from external threats like malware, etc. And you would see there is one more function of user interface. So OS provide ways for users to interact with the system. There are two types of user interfaces. First is graphical user interface, and then there is command line interface. So graphical user interface is visual based. There are graphics involved like Windows, Android. These are graphical user interface. So we have icons over here. We can drag the files, we can write anything, right? And then we have command line interface. Command line interface requires we need to text commands to instruct the computer. So here we are not dragging, dropping the icons or clicking on icons. We are writing a particular text as a command, and then the computer, then the operating system executes that. So for example, you want to create a new folder. So in Windows, what you'll do, you'll have a right click, and then you see new, and then you see folder, and then you create one, right? So in command line interface, you have to write the command to create a new folder, which we'll learn when we'll learn Linux programming. So all this clicking icons, dragging files, typing command, all are made possible by operating system. So to summarize, an operating system is a software that connects the user, application and hardware, and its main goals are convenience, efficiency and evolution, and its functions include managing processes, memory, files, devices, security and the user interface itself. Now that we know about what operating system is and its function, let's explore different types of operating system. Each type of OS is designed for specific purposes. Some focus on efficiency, some on real-time performance, and other on ease of use. So let's go through them one by one. First, we'll talk about simple batch operating system. So a batch operating system is one of the earliest type of operating system which was used when the user was not ready to interact with the system directly. So what would happen is the user won't interact directly. Instead, they prepare jobs. They prepare like program or particular data. So they are known as jobs, and then they submit that to an operator. Then the operator batches the similar job together, and it is known as a batch, right? They group the similar jobs together, and then the system executes them automatically. So these batches are then sent to a computer as a group, and the output for each job would be sent back to the appropriate user. So this is how simple batch operating system performs. So you see, if early IBM mainframes, there were computer IBM mainframes, they uses batch OS, and even today, so payroll systems or bank check processing, they may use batch processing system today as well. So advantages include that there is better use of resources as jobs are grouped together, and it also eliminates the idle time because the next job starts automatically, and it is simple to manage and manage the repetitive task. But there are few disadvantages as well, that there is no user interaction. So there is no interaction between the user and computer during execution, and debugging is very difficult. And the turnaround time, that is the time when the job is sent and the output is sent to the user, the time taken is high because you must wait until the whole batch finishes. Even if your job inside the batch is completed, you still have to wait for the entire jobs in the one batch to be completed, and then you'll receive the output. So this is how simple batch operating system work. Next, we'll talk about multi-programmed operating system. So a multi-programmed operating system allows multiple programs to be loaded into the memory at the same time. So when one program is waiting for input output, for example, one program is waiting to read something from a disk. So what happens is CPU switches to the another program. So here the CPU utilization is increased. The idle time is when CPU is not doing anything. The idle time is reduced in this multi-programming system. So this was the evolution of a simple batch processing system to improve the CPU utilization. So what will CPU do when there is no batch, right? When a particular job is going to have some input. For example, there is a program that requires user to input two numbers. So meanwhile the user is inputting two numbers, what is CPU doing? That idle time should be utilized to have an efficient working operating system. That is why we come up with multi-programmed operating system. So this idea is to keep several jobs in the memory at one time, and the moment one job is left the memory and gone to have an input like reading or something, the CPU switches to the another program. So this increases the CPU utilization. So you see, the modern version of Unix and Linux, they have this multi-program batch systems. And suppose you're downloading a file, or you're playing a music and typing in Word. So you're doing all these three things at a time. So if you have a multi-programming OS, that is why the operating system ensures that all the three happens smoothly. So there are few advantages to multi-program system, that it increases the CPU efficiency, it improves this system throughput, and also reduces the idle time. But there are few disadvantages, that it requires proper memory management. So if there is no memory management, it is very hard, right? So then there is one more disadvantage, that there is no user interaction again. So there is very few, still it is a non-interactive oriented, right? And if one program crashes, it might affect the others. So this was very prevalent in older systems, the system which were existing before, that if one program in the memory crashes, it might affect the working, right? So it is also complex than the simple batch operating system, but it have advantages as well. So it is used in large scale scientific calculation. So you would see multi-program batch system significantly used in scientific calculations because they have a good processing and require a little user input, and it is also used for check processing in banking systems. Now let's talk about time sharing operating system. So a time sharing operating system extends multi-programming by allowing multiple users to interact with the system at the same time. So what is happening here? Multiple users are interacting with the system as well. So time sharing is a logical extension of multi-programming. Here the CPU switches the job so frequently that users can interact with each running program while it is running. So you see, this is a very good extended version. So there is a rapid switching happening, and it is known as time slice. So what is time slices? So CPU time is divided into small units. So CPU time, we divide it into small chunks, small units. These are known as time slices, and each user or each task get a slice in turn, right? So these time slices are dedicated to each and every user. So what happening here is that we are giving an illusion that each user have their own dedicated machine, but this is not how it is. So this is a time sharing system where we have modern multitasking operating system. Time sharing system is widely used in universities or offices where multiple terminal access a single mainframe computer. And it is also used in cloud servers that handle many users simultaneously. So there are few advantages of time sharing system, that it provides quick response to user. So it, for example, you are having ChatGPT prompt running, and then meanwhile you just open something else. So it seem like you are the one responsible for handling everything. It is going to do, but no, operating system is working behind, and it is giving time slices. So we get the illusion that yes, we have our own dedicated machine, and whatever we are doing, this is the one running right now. No, but there is some other process running behind by the operating system which we don't know. So this is the advanced version of multitasking operating system. There are few disadvantages, that it requires large memory. Okay, so there is sophisticated it needs sophisticated scheduling and memory management, right? So it requires very large memory and powerful hardware as well. And then there is security issues as well. Security and data privacy can be a concern over here, and it is more complex to implement. And there are reliability, there is failures in this OS which can affect all the users which are accessing it simultaneously. And time sharing system is used in modern desktop operating system like Microsoft Windows, Mac OS, Linux. All use time sharing system, which allows us to run a web browser, word processor, music player at the same time, right? And also it is used in mainframe computers. It is used by large organizations to serve hundreds of users simultaneously. Now we'll talk about personal computer system. So personal computer system are specially designed for individual use, for single users to manage their personal devices like desktops, laptops, or mobile devices. So these operating systems balance between convenience and performance for everyday tasks. So their priority is the user convenience, responsiveness, ease of use, rather than maximizing the CPU and input output utilization. So they are almost all multitasking. So they are single user, but still they are multitasking, because if a user have that feeling of running multiple application at once, it increases the user satisfaction to a level that it makes the operating system very efficient, right? So there are few advantages of a personal computer operating system, that it is easy to use, it is user friendly, it is designed with rich graphical user interface, for ease of use. And then it also supports wide range of application, and it provides networking, multimedia, personalization, and there is wide range of support for home and office use. And it provides good performance. It is optimized for interactive applications like gaming and media. But there are few disadvantages, that it is not as powerful as the server operating system that is used for handling thousands of users. And it can be prone to viruses and malware, and it requires frequent updates and maintenance. There is limited power, and there is basic security system. It is not very good security provided as compared to the multi-user system. So the real life examples would be like Windows, Mac operating system, Linux for the PCs, and then in mobile application we see iOS and Android for the smartphones, right? Let's move on and discuss about the parallel operating system. So a parallel operating system is designed to run on system with multiple processors. So there are systems where you not only have one processor, but you have more than one processor. So here the tasks are divided into smaller subtasks, and then different processors, different CPUs execute them simultaneously. So there is one task, and it is divided into multiple different subtasks. Okay, and these each subtask would be given to the different processors for the execution. So what is happening here, we are increasing the performance. So you see, in supercomputers like those which are used for weather forecasting, space research, and scientific simulation, use this parallel operating system. So here they share the computer bus, and sometimes they also share the clock, memory, and peripheral devices as well. So main goal is to increase the throughput. Throughput is the amount of work done in a given time. So we are increasing the throughput, hence increasing the efficiency and utilization of the system. So it is also used to improve the reliability on the system. So this is also known as tightly coupled system. Tightly coupled system means here these the components of the system are very much heavily dependent on each other. So it is tightly coupled. Now you see, we have few advantages, like it increase the throughput. That means that the performance of the system is very much as compared to the time taken, and it is often cheaper to use multiple standard processor than one custom high performance processor. So when we use multiple, tasks are divided and the time efficiency increases. And there is also high reliability. So if one processor fails, other can continue. So there is a high reliability of this system, and not a particular resource or a process or a system decides the working of the entire system, right? And there are few disadvantages as well, that it is very expensive, and there is high cost in maintenance as well, and also it requires complex programming. So here the writing software can take advantage of multiple processors simultaneously is difficult. So the programming which is required is difficult. There is complex design and implementation, and it requires and it has very expensive hardware. Next, we'll talk about distributed operating system. So a distributed operating system manages a group of independent computers and make them appear as a single system to a user. And all the resources in distributed operating system are connected systems, are shared temporarily. So here all the resources are shared transparently to everyone. So you see, there are multiple system over here. First we were talking about in parallel there were multiple CPUs, multiple processors, but here there are independent computers, independent systems which are located at different locations. Okay, and distributed operating system makes them appear as a single system to a user. So you see, for example, you have a Google search and Gmail servers. So they are based on distributed system. They are completely different. They are located at different locations, but they seem as a single system, right? So you see Hadoop. Hadoop is used to clusters, to make the clusters for big data. So these are example of distributed operating system. So here there it is a collection of physically separate and independent computers, and they are networked together. Okay, so they appear as a single operating system to the user. So unlike parallel system, these computers do not share memory. So there is no sharing of resources, there is no shared memory, shared clock, and they're loosely coupled. They are very less dependent on each other. They have their own resources, they have their own local memory. So advantage is that there is resource sharing across the system, so user can access resources on any machine in the network, and there is high reliability. So even if the one system fails, the other continue, there is no difference made. So it is very reliable, and there is scalability. That means you can add n number of computers in the network, in the distributed operating system, without decreasing the efficiency of the system. Okay, and there is computation speed up, means a large task is also divided among different nodes, different computers to be processed concurrently. Okay, so it is very good type of operating system. Then we have disadvantages as well, that there is security issues because of the networking, and because the system performance is highly dependent on the network reliability and speed, so there can be security issues which make it a complex problem. Then the setup of distributed system is quite expensive, and also the maintenance require a good amount of complexity. So developing and managing the software for distributed system is also another significant challenge. And this is highly used in the, you can see the example of internet. It is the ultimate example of massive distributed system. So there is a network around the world, and the internet is connected through it. And then you see cloud computing platforms such as AWS and Google Cloud. They are also the type of distributed system we heavily see in today's world. Lastly, we have real-time operating system. So real-time operating system is designed to respond immediately to inputs or even events within a guaranteed time limit. So real-time operating system is crucial. It is used where timing is very critical, where our priority is the timing, that in this particular time period the task should be completed. So that is where the real-time operating system plays a role. So here the correctness of computation depends not only on the logical result but also the time at which it was produced. So these systems have well-defined fixed time constraint, that you are given 4 seconds, and 4 seconds should be enough to complete that, and if you are not able to do that, then you have a serious consequences. Okay, so if you fail to produce that, it is considered as the system failure, that our system is not working, our operating system is not working. So there are two types of real-time systems. First is hard real-time, and then there is soft real-time. So hard real-time guarantees that critical task will be completed on time. Okay, and if you miss a particular deadline, then it will have a very bad consequence. It would be considered as a failure. But soft real time is unlike the hard real time. Here the critical tasks receive priority, but there is no guarantee about when they'll be completed. So here we are not mentioning a fixed timeline, and even if you miss a deadline, there is it is considered undesirable, but it is not catastrophic. Okay, it is not like the end of the world, but in hard real time system it is the end of the world. So there are few advantages of real time operating system, that we are able to predict, and that it provides us the predictable response for time critical events. So there are few case scenarios, such as when you have a system, you see, we have to control aircraft, so you really need an operating system which is very time critical, right? So in this particular time, you really need to have predictability and reliability, and it is very suitable for high priority or for critical tasks. To ensure that the most important processes are executed first, we use real time operating systems. But there are few disadvantages as well, that there is high complexity, it is difficult to design, implement and maintain, and there is limited scope. It is designed for specific tasks and not for general purpose computing. So it can only be used in the tasks where the time critical responses are very critical. Okay, so it is not generally used, it is just used for specific purpose. And then it is also resource intensive, it requires significant resources to achieve that time efficiency, to achieve that precision. It requires a lot of resources. So these are few disadvantages. So you see, the hard real time is used in flight control systems in aircraft, and soft real time is using like digital audio video system, where you are streaming media, where occasional delays are acceptable, they don't cause any end of the world scenario. So to recap, we studied different types of operating system, and each type has its own strength and weakness and is used in different real life scenarios, from smartphones and laptops to supercomputers, servers and even airplanes. So in batch operating system, we learned that it handles jobs in a group without user interaction. Then we have multi-programmed OS, which keeps the CPU busy by running multiple programs. And then there is time sharing system, which allows multiple users to work simultaneously. The personal computer operating system is designed for personal use, like Windows, Linux, Mac OS. And then there is parallel operating system, which uses multiple processors for speed. Distributed operating system makes many computers work as one, and then the real-time operating system provides guaranteed immediate response. In the next video, we'll dive deeper into Linux programming. What is Linux programming? What is the architecture? What is the basics of VI editor and basic commands of Linux programming?